Hi everyone, welcome back to Math 11. Why don't you ask me to go over some of the homework questions? So this is the first question from section 5.1, question number 2. It says, use the range and measures of central tendency, which is the mean, median, and mode, to compare the results of two geography tests given by the same teacher to the same class in the same semester. So we have Unit 1 and then Unit 2 test on the right side. So we have two separate tables. We have the same number of students who wrote it. And the question says, did the class perform better on the Unit 1 or Unit 2? So before you do that, we have to figure out the range, the mean, median, and mode. So I'm going to do one of the unit tests, Unit 1, and then it's going to be the same type of calculations for Unit 2 tests. So to find the range, what you need to do is to find your maximum, minimum. Now, these already range from max and min, so we know that our highest one is 81 here, and the lowest one is 57. So to find the range, so for unit test number 1, we have range, which in this case is going to be 81 minus 57 equals to 24. And I already tabulated the answers here on the right side. Then to find the mean, which is the average, we have to add all these numbers together, and these are way too many to write them all out here, but on the calculator you're just going to add all of these together. So you're going to do 81 plus 76 plus 73 plus etc., and all the way down to the last two, which is plus 66 here plus 57. And then you're going to divide this by the total number of test scores that you have. In this case, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there are 25 in total. So you're going to divide this by 25, and you're going to get your mean, your average of 71.2. So that's the average score or the mean score. For the median is the value that's in the middle. So basically 50% to the left, 50% to the right. Because we have 25 scores in total, that means that for the median, there are 25 in total. So there are 25 tests. So test number 25 divided by 2 is going to be basically 24 divided by 2 would be 12, so it'd be the 13. So test number 13 is the median. Is the middle one or the median? So the 13th test is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 73 is the median. So the median is 73. So again, it's the test that's in the middle. Because there's 25 tests, the middle number is going to be number 13. So you count from either from the largest or from the lowest backwards. You count backwards. So anyway, 73 for the median. Then we have the last one, which is the mode. Now the mode is the test that occurs the most times. So if you look at all the values here, we have 275s, but then we have actually, let's see, for the median, are these arranged from highest to lowest? Looks like they are. So they actually arrange this way. So they go down, and then they go down this way, down that way, not left to right. They go from top to bottom on every column. So anyway, the test that's most frequent, that we see appear multiple times, is going to be, looks like 73, 1, 2, 3, 4, 5 times. We see 75 appearing twice. We see 79 appearing twice. So 73 appears the most times, appears 5 times. So 73 appears the most times. Therefore, it is the mode. Okay? So that's why 73 is going to be the mode for unit test number 1. So like I said, I already put the values here. So for test number 1, we have the range of 24 that we found here. The mean 71.2, the median, again, the median is the number that's in the middle, which happens to be number 13, which is 73, and the mode is the number that occurs the most times, which is 73. So you would do the same thing for unit test number 2, and you're going to find the following values. You're going to see that the range here is going to be 61. So from 98 minus 37 is going to be 61. So that's quite a big range, quite a big spread. So question B says, so this is your part A. So making this table, finding all those values. So then part B says, did the class perform better unit test 1 or unit test 2? Justify your decision. So if we look at these values, the median is the same, the mean is the same, the mode is the same. So the central tendency values, all of these are the same. So for part B, it's hard to tell from just the central tendency values because they're all the same. But if you look at the range, the spread is much smaller in unit test 1 compared to unit test 2. So in unit test 1, people were between 81 and 57. So that's like B and C minus. Here we have 98 and a fail basically. So we have A plus and F. So the spread is way better, way smaller in the unit test number 1. So even though the mean, median, mode are the same, there's less spread in test 1. So in this case, did the class perform better unit 1 or unit 2? Unit 1 has lower spread. Because again, the central tendency values are all the same, we have to look at the range. So like I said, range is something that is not the measure of central tendency values, but in this case, it still tells us which unit test was done better because this one has, unit test 1 has lower spread. So people were clustered more together compared to unit test number 2. So because of that, unit 1 has lower spread compared to unit 2. And part C says, were the modes useful to compare this situation? So the modes here are both the same. So the modes for part C are both 73. So for part C, it depends how you look at it. If you just look at the central tendency values, then they're not useful because they're the same. So they're not helping us distinguish between test 1 and 2. But as a teacher, for example, if I look at this and I see that in both tests, most people, so mode is the most frequent score, most people scored 73, that tells me where most people are. So it depends how you look at it. If it's just a matter of looking at the, comparing the test between the two and just seeing what are the values for the mode, then it's not useful because it's exactly the same. But if you are looking to see what was the most frequent score, for example, from the perspective of a teacher, then it might be useful to the teacher. So it depends on how you interpret this data. So as a teacher, I would find it useful to see that most students are getting 73%. And if you're just looking as a statistician and you just want to know the difference between the two, then it's not going to help you because they're the same. Okay, so again, depends how you look at it. Now, the other couple of questions that people requested was from section 5.2. Now, from 5.2, the first question was 6. So the question 6 says, on the same graph, draw the frequency polygons to show the population of males and females in Canada in 2009. So this is the table from the textbook. Okay, so what I've done here is I put this in a spreadsheet. And again, you can do this by hand. You don't have to do this on a spreadsheet. You should be able to do this by hand because it's basically just making a line graph. But I did do it on a spreadsheet, so I can show you what you can get from the graph. So once you enter all the values, basically copy the table from the textbook, what you can do then is to just select this whole thing. So again, you have to enter it in a spreadsheet and then go to Insert, and you're going to click on a graph, and you're going to click on a line chart. So this would be our graph for this data set. So again, the blue line here is the percentage of males, and the red line is the percentage of females in Canada in 2009. So we can add so let's see what this was. This is the population. The title is Population by Gender and Age Group. in 2009. Okay, so this is Canadian population about 10 years ago. So that's our graph. As you can see, it's basically a line graph. So the blue one and the red lines are male and female. And again, this is in percentages. So at the bottom, we have the age groups. So 0 to 4 years, 5 to 9, 10 to 14, and so on. So as you can see, of course, people die at around 82, I think, the life expectancy in Canada. So the population decreases pretty much almost to zero when you go past 90. So that's our graph. So you can definitely do this by hand if you have a grid paper. You already have all the age groups. You just have to figure out how many, basically where to plot these values. For example, the percents go on the left here, right? So this is percents. So even though it doesn't show the label here on the left side, but your y-axis is your percent values. So these are your values for the male and female. So like here 5.6, 5.5, 6.0, and so forth. And again, the easiest way would be to make this on a grid table, grid paper, and you can just use these values to approximate the points on your graph. Of course, you can use spreadsheet like I did here and just do it on the computer. So you can see the spreadsheet in the class notes. So if I save this, it will appear right here next to the question. So anyway, whether you did this by hand or on the computer, it doesn't matter. You should have a similar graph, or you can just look at the answer key in the back. We'll show the same graph as well. So then you can answer the question that says, examine your graph. Describe any differences you notice in the population of the two sexes. So this is part B. So for part B, we see that, for example, around here at the 55 point, looks like the number of females is greater than the number of males. And before that, the number of males is greater compared to the number of females. So that'll be the difference that you can see here. So for part B, you can say from, let's say, 0 to 55, or there are more males. This is in percent. And then from 55 to 90 plus, there are more females. So women live a little longer compared to men after the age group of 55. So that's what we see from this graph in question 6. Okay, so again, for graphing, you can definitely use a computer if you want. It just takes a bit of work to just input all this into a spreadsheet. So if you're not familiar with spreadsheets, just do it by hand, okay? You can definitely do this by hand. So the last question was question number 11. It says, what are the advantages of grouping raw data into intervals? So for example, if you look here in the previous question, this was already grouped for us, right? So people picked all the ages and they put them in the intervals from 0 to 4, 5 to 9, 10 to 14, and so on. So the benefit of grouping, if you have a large amount of data, it's easier to read it if you group it into intervals. Like I said, the example with the grades, if you just compare percentages, you can have 100 groups if you compare every single percent, or even more if you compare it like with decimals. So that's why we have letter grades. For example, instead of having 100 different groups, we have 6 different letter grades that we can use to show sort of the approximate level in, or the number of students in each of the intervals for each letter grade. So the advantage is that you can easily manage large amounts of data. So for part A, you can say something along the lines of that's easier to manipulate large amounts of data. So it makes large amounts of data easier to understand, okay, or interpret. And part B says, how does a histogram differ from a frequency polygon? So remember, a histogram, it's kind of like a bar graph that you have. Basically, the only difference between a histogram and bar graph that histograms are continuous versus bar graphs are just categories. But the question here is not between the question asks not the difference between a histogram and bar graph. It's asking us the histogram from a frequency polygon. So a frequency polygon is a line graph which connects the middle point of a histogram. So for example, this is a line graph right here, which is in this case, a frequency polygon. And if you have to compare multiple data sets, like we did in the previous question, we had the percentage of males and percentage of females, it would be hard to see the difference if you have histograms because you're going to have bars laying on top of the other graphs. So it's hard to see it. So if you have multiple sets of data that you want to compare, it's easier to compare with the frequency polygon than a histogram. It's easier to see. So you can have like 2 line graphs, you can have 4, 5, 10. It'd be easier to see compared to a bunch of histograms. If you have maybe 2 histograms, if they're different enough, it would be easy maybe to see the difference. But if you have multiple histograms, it'd be impossible to see the data. So for comparison of different data sets, it's easier to see a frequency polygon than a histogram. Okay? Because again, histograms are kind of like bar graphs. They're going to be laying on top of each other and be preventing you from seeing the differences. So for comparison, whenever we had to compare multiple data sets, 2 or more, then a polygon, frequency polygon, is going to be easier to see than a histogram. That's the main reason you want to use a frequency polygon compared to a histogram. If you have one single data set, histogram or a frequency polygon can be used. Either one is fine. A lot of times the histograms will be used more often. If you have one set, if you have multiple sets and you want to overlay one over the other, then you have to use the frequency polygon, not a histogram. You can have a bunch of histograms side by side, but not on the same graph. So frequency polygons allow you to do this on the same graph. Okay, so that's all the questions I had from sections 5.1 and 5.2. So remember, there's a quiz after this.